Good morning, good afternoon, good evening, assalamu alaikum. I'm actually going out for hiking today, and one thing I wanted to talk about, because I see some of the questions that came out from some of the videos that I have produced, is, what is that large language model, small language model, the context, and what are we talking about? So many different things. And when you try to run something and generative AI, sometimes it takes a lot of compute power, CPU cost. We cannot do that. Sometimes it's very easy. I just pay $20. So what's the fundamental difference on those things? And I figured out that I'll take a quick minute and a few minutes and explain those things to you. Okay, so large language model versus small language model. Let's just focus on that particular area today. So the large language model is the models that we currently use. Hundreds of billions of parameters. So to understand, let's go back to the parameters. Like, if you think about it, like I'm in this great area, and it's called South Mountain Reservation area. Here is a lot of trees, and you're trying to figure it out. How many things that you see, all those aspects of it creates a parameter. In a simple term, let's say I'm gonna train a model with internet, meaning I have cooking recipes, I have intellectual theses, like for example, how atoms and nucleus, those things work. I have chemistry, I have social science and history, everything together, more of a generalistic, all of them together, I do that training, okay? So that means that I actually train with very massive and large data set. So when I ask a question, all these questions can be answered with one model. So that this is extremely important, meaning that if I ask a question, how to cook biryani, it can tell me that. At the same time, if I ask a question, how do I create a retrieval augmented generation using N8N and Docker container, it can answer that as well. Completely two different dimensions, or even some medical questions, even some historical questions, or policy related questions. So when it can answer all different things, because I trained the model with all different parameters, all different data sets, that gives me a capabilities being a generalist across, and also in depth across a lot of different fields. And that, for that reason, you needed so many different parameters that you want to kind of like think about. You go to one place, you ask a question, you get all the answers. Encyclopedia type of things. So large language model gets trained in such. Remember, in our old days, the encyclopedias, we had a lot of volumes, like you can still see in a lot of offices. It was in our background. It was a lot of fun at that time. So meaning that when you train with everything, it's a large set of data. Same like encyclopedia, like there's a 1, 2, 3, 4, 5, 6 volumes, 30 volumes. You need one answer, you just pick one and get that answer, okay? Now that's a large set of large language model. Now what is the small language model? Small language model, on the other hand, is domain specific, meaning that I want to take a small set of data. A properly structured small language model would only talk about a particular domain specific thing. Let's say you're a bank. You want to answer the bank related questions for your customers, for your users, internal and external users, or for anybody. So what do you do at that time? You actually figure out, I will be answering this question only specific to that particular domain, that particular function. Let's say even within the bank, you are a mortgage company. So you're going to be answering all the mortgage related questions, the loan specific question and such. So how do you train that one? Instead of training this model for cooking recipe and all other things, you make it very, very specific. Now, if the hallucination happens, it happens within that particular domain, not beyond that domain. So you structure in such a way the small language models is to answer that specific things. Now the difference also between the large and the small, because the large requires thousands of GPU, graphical processing unit, servers, and small language model requires a very small, maybe it can run in only in one GPU. So hopefully you get the context of it. So large language model is a generalist across a lot of things. Small language model is specialized in one thing. Now let's go a little bit technical deep. What makes a specific distinction between large and small? So what was happening is a large language model has hundreds of billions of parameters. Like GPT-3 was 170 billion parameters. Think about that. And then afterward, we started to see even trillion parameters. Not only the parameters, it has fine-tuning capabilities and such, some other things. But let's focus on the parameter, because parameter is the term that consider the size of that particular model, okay, in generative AI term, more or less. So you have particular set of parameters that it has been trained, meaning that I'm looking at this person from various angles, okay? When you ask a question, I'm gonna look into this from that particular angle. So in that case, if you have a trillion parameters, 1 trillion, 1,000 billion parameters, so you're looking at all different perspectives. Small language model, in technical term, is typically less than 70 billion parameters. Some people say less than 100, some people say less than 70. Let's take the smaller version of it, less than 70 billion parameters. So what happens at that time, you are able to run in your laptop, or sometimes you have like only few 100 million parameters, 300 million parameters, you can run in your cell phone. So the small language model gives you capabilities to run within your environment. And that's a very big thing, meaning that I'm not going to the cloud, I'm not sending my data outside of my control. And the large language model, because of the fact I need thousands of servers, I have to send my data outside. So small language model, when you want to keep your data to yourself, small and contain the cost becomes significantly smaller. And that means it gives you a capability to control the data, control the cost, and make it more efficient for that small domain, okay? It cannot answer anything else though at the same time. It is not large, it might not be as efficient, okay? Because of the fact I don't have enough compute power or CPU or GPU and such, okay? And the large language model, obviously, it has thousands of servers, so it can be more efficient. So now, one more thing that comes into play, one more thing that comes into play is, so if I run that, do I always need some costly compute like GPU servers? Small language model actually gives you a capability to run even in CPUs, some of them, even in your mobile, which is the specific chip, smaller size chip that runs in your mobile phone, or edge devices like an IoT sensor, like, you know, you have a smart home devices, or you know, you make these robots and they can run those things locally. So again, the versatilities started to come into play, and there is a lot of those open source models, and you know, Google is typically in the frontier side of it, and Albert and such, you know, those things that you can look into it. Large language models are the ones that we use every day, which is OpenAI models and such. Now what's happening is, because the large language models are so popular, so good, people started to make those large language models a smaller model. And that is called quantization. I talked about quantization a number of times. And I think that might not have resonated the way that I'm explaining the concept itself. So what does it mean? Meaning that I have a large model, let's say it's a 500 billion or a trillion parameter model. I quantize based on various mechanisms. I'll talk about quantization in another video. And then I can make that a smaller, it's called 16-bit to 4-bit conversion basically. So I make it a very small size, and then that becomes, instead of needing 80 gigabyte of memory, it only needs, let's say, 16 or 14 gigabyte of memory. And that's the fundamental difference, because I needed a big server or a big compute or big memory footprint. Now I don't need that anymore. So it's the same model, but less parameters, and I can focus on these things. So remember, this doesn't have as many parameters as I had before. It has a smaller set of parameters, and it's running in my local machine, my laptop and such. So if you're running a same model, has a large language model and a small language model, that you can actually start using those things. So fundamentally speaking, large language model versus small language model, these would make a big difference based on your use case. So let's talk about the use cases. When you need to go out the internet, scrape everything, learn about everything, and kind of like start creating a solution, creating a context, creating a response, creating text, multimodality, all of those things from one single model, start using large language models. Even large language models started to have the variation of different modalities of it. But again, start using the large language models. Now, on the small language model, I have, let's go back to a bank. I wanted to create a customer chatbot, like a response to customer, convert voice, take a lot of documents, contract documents, legal documents, only answer those things. So I can customize those things and only do a specific function in depth, without hallucination, without going the boundary of that knowledge. And that is perfect for a small language model. So these are the use cases. One more thing I wanted to talk about: why small language model now and not before? We keep hearing about that. So there are a bunch of benchmarks, like, you have that international style map test, multitasking, MMLU, AIML, a bunch of different benchmark tests. What used to happen is, in the benchmark test, earlier it didn't perform as well, meaning human would perform certain level. For example, in MMLU test or benchmark, human performance would be, like, I would say 37%, I believe that's the number. And it was not as good, maybe a little bit better than human, not at the expert level. The expert used to be at 90, meaning if you are a PhD level person, you'd answer that particular question at 90% accuracy. What started to happen is the large language model was answering at, let's say, 80+%, but the small language model were not answering that. So you need to have that, let's say, a benchmark of 60% plus accuracy rate. Okay, so most of those small language models are responding significantly more than 60% accuracy, and that means that now I have a reasonable expectation of the small language models that I can take and get the proper answer with the depth of that particular domain, respond to the customer very quickly, and my data stays within my boundary of control, and it doesn't go anywhere. It doesn't go to the internet. And that makes a fundamental difference. And of course, with GPT OSS, the video that we just created before, and of course, there is reasoning models like DeepSeek and the Qwen, and from Gemini. So and of course Llama from Meta. So there is so many of these models are created now with a large parameter set and also with a small parameter set. This is why small language model is becoming more and more popular. People started to use that because they don't want to send out their proprietary data that is specific use case, and they want to contain the cost. They want to secure it and protect it. So with that, hopefully you understand large language model, small language model. And the large language model versus small language model comes in, are you a generalist or are you a specialist? And do you want to go in a broad sense or a specific sense? That's the use case, but it gives you a lot of benefits to it. So hopefully everybody understood this time. And with that, I want to finish it up. Assalamu alaikum. This is a great view. I'm going to show you what the view is all around. This is a great path. This is called South Mountain Reservation in Milburn, Springfield area. Typically, I go here for the weekend and take about an hour or so for hiking. But going up takes a lot of effort, and as you can see that I'm breathing high. So really for listening to me, learning about it, do something positive, do something amazing, and always contribute for the future of this planet. Thanks. Assalamu alaikum.